Hello student, good morning. I am Dr.A.J. Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical reactions of amines. And I have finished many reactions I have finished. Now remaining chemical reaction I will discuss today. Now I am going to discuss reaction with aryl sulfonyl chloride. Reaction with aryl sulfonyl chloride. Benzene sulfonyl chloride, that is a C6H5SO2Cl. This is actually called benzene sulfonyl chloride. Benzene sulfonyl chloride, which is also known as Hinsberg reagent. Question is asked, what is the Hinsberg reagent? Hinsbergs, Hinsberg's reagent. Then benzene sulfonyl chloride means C6H5SO2Cl is known as Hinsberg reagent. This reagent reacts with primary and secondary amine to form sulfonamide. It will form sulfonamide. Reaction I am telling you. The reaction of benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonyl amide. See, reaction is very easy. Only a structure is big. One benzene is there, C6H5SO2Cl. Then phenyl group is there with S. Phenyl group is attached, and same S, Cl is attached, and SO2 is already there. S double bond O, again H double bond O. 2 oxygen is there. C6H5SO2Cl. Then phenyl group is attached with sulfur. Cl is attached with same sulfur, and 2 oxygens are there. Both oxygens are attached to sulfur only. Only one sulfur is there, and both oxygen is joined with double bond. Then now reaction I am telling you, that reaction now it will this sulfonyl chloride, it will react with primary amine. Okay, it will react with primary amine. Then primary amine here means now C2H5NH2. Only one H is replaced with C2H5. That is called, out of 3 only one H is replaced with ethyl. Now it became NH2 C2H5. Then these two will how will they react? Benzene sulfonyl chloride plus NH2 C2H5. Then very easy reaction. Cl from the benzene sulfonyl chloride, that Cl, and H from the amine. Then H will go as H plus. You know that what will happen? H will go as H plus, N will become negative, Cl will go as a Cl minus, and sulfur will become positive. Then sulfur and nitrogen, sulfur is positive charge, nitrogen is negative charge. Both will join. All things will be as it is. Correct? Both will join. Then you will get product that will be long. But main reaction is between H and Cl. Cl will go as Cl minus, H will become positive charge. And from the amine, H will go as, one hydrogen will go as H plus, N will become negative. Then this positive sulfur and negative nitrogen both will join. All things will be as it is. Then product name will be N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. Okay, other product is HCl. Then this compound N-ethyl benzene sulfonamide, this is soluble in alkali. The hydrogen attached to nitrogen in sulfonamide is strongly acidic due to the presence of a strong electron withdrawing sulfonyl group. This is the important point. The hydrogen attached to nitrogen in sulfonamide means what product you got? Sulfonamide. That hydrogen is strongly acidic. Why? Due to presence of a strong electron withdrawing sulfonyl group. Because it is attached to the sulfonyl group, due to that will attract the electron, then hydrogen will not get the electron, it will go out. That's why it will be a strong acidic. Okay, it will come strong acidic. Then this I told you, the hydrogen attached to nitrogen in sulfonamide is strongly acidic due to the presence of a strong electron withdrawing sulfonyl group. Hence it is soluble in alkali. Because it is acidic character, then any acid will react with base. That's why it is soluble in alkali. Now second reaction. Second reaction is again same way. That is same things are there. Benzene sulfonyl chloride, it is reacting with amine. But only thing is that now it is the secondary amine. Means 2H gone and 2C2H5 joined. With each one H, one ethyl group joined. Then now it became secondary amine. Then reaction will be again same way. H from the N, it will go as a H plus, N will become negative, and Cl from the this sulfonyl chloride, Cl will go as Cl minus, and sulfur will become positive. Same way, then positive sulfur and negative nitrogen both will join, and other product will be HCl. Then now here only thing is that here it will be not acidic because no H is present there. In the first case, one H was there with NH because it was the primary, then 2H was there, then 1H gone with HCl, with Cl as HCl, then 1H was remaining. But here now only one H was there, that gone as HCl, no H is there. That's why it will not dissolve in alkali, it is not soluble in alkali. Okay, this is the main reaction. Since NN diethyl benzene sulfonamide does not contain any hydrogen atom attached to the nitrogen atom, it is not acidic and hence insoluble in alkali, means it will not dissolve. Now third point I am telling you, third reaction, tertiary amine. Tertiary amine do not react with benzene sulfonyl chloride. Now you can understand why it will not react. Question is asked. Tertiary amines do not react with benzene sulfonyl chloride. Reason? Because there is no H. All are ethyl group. Means all are substituted. No H is there. Then how it will react with that Cl? That's why there will be no reaction. Tertiary amines do not react with benzene sulfonyl chloride. This property of amines reacting with benzene sulfonyl chloride in a different manner is used for the distinction of primary, secondary and tertiary amines, and also for separation of a mixture of amines. Okay, how will we differentiate primary, secondary and tertiary amine? Then now easily you can understand. In the primary it is soluble, product is soluble. Secondary it is not soluble, and tertiary there will be no reaction at all. Okay, Then this property is actually used for the distinction of primary, secondary and tertiary amines, and also for separation of a mixture of amines. However, these days benzene sulfonyl chloride is replaced by para-toluene sulfonyl chloride. From that also it can be, all this reaction can take place. Now next reaction is electrophilic substitution. Electrophilic substitution reaction. Already you know the meaning of electrophilic substitution, E plus, that will substitute with other, generally H plus or any other cation which has positive charge. Okay, same charge. Then basic things you are knowing. You know aniline is a resonance hybrid of 5 structures. Okay, and you also know that maximum electron density in these structures, where will be the electron density more, that also you know, that is the ortho and para position, because ortho position and para position negative charge is there. Then ortho and para position to the NH2 means aniline NH2 is there, then with respect to ortho and para there will be negative. Okay, then this you are knowing, ortho and para position to the maximum electron density, or you can tell that maximum electron you will find at ortho and para position, always you remember. Okay, in case of aniline. And these ortho and para position, maximum density in this structure, you know that ortho and para position to the NH2 group become centers of electron density. Thus NH2 group is ortho and para directing and a powerful activating group. Correct? When NH2 is attached, then ortho and para position will be negatively charged, means having a high electron density. That's why it is called ortho and para directing and a powerful activating group. Then now bromination, in that under the electrophilic substitution I am telling you bromination. Actually this type of reaction already I have discussed. Okay, automatically here main thing is that bromine will break. Bromine will break. When bromine Br2 will break, then one will get Br plus, other will be Br minus. Correct? This is the only important point. Then in benzene ring at ortho position, from that H will go as a H plus. Correct? Then this H plus will come to the Br minus. It will form HBr. And Br plus, that will come in the place of H plus, same charge. From where it gone, there Br is positive and that carbon will become negative. After when hydrogen gone as H plus, carbon will become negative, that at that carbon Br will join. Correct? Like that way para position also same thing will happen. And again one more ortho position is there. There means 6th carbon, there also same thing will happen. Means if 3 bromine molecule you will take, then 3 Br minus you will get. Then these 3 Br minus will join with this ortho position, para position and again ortho position. Means 2, 4, 6. Then 3H will come out from this carbon. 3H plus will join to the 3 Br minus. It will form 3HBr. And product you will get 2,4,6 tribromoaniline. Okay, product is very important. The main problem encountered during electrophilic substitution reaction of aromatic amine is that of their very high reactivity. Reaction is very highly reactive. Substitution tends to occur at ortho and para position. If we have to prepare monosubstituted aniline derivative, how we will make? How can the activating effect NH2 group be controlled? Because you want suppose only monosubstituted. Now it is a tri-substituted, di and tri. But suppose you want monosubstituted, then you have to control it. Then how will you control? That this can be done by protecting the NH2 group by acetylation with acetic anhydride. Means NH2 group you have to protect. Then how? Then NH2 group, this can be done by protecting the NH2 group by acetylation. How will you do acetylation? Then with acetic anhydride. Then carrying out of the desired substitution followed by hydrolysis of substituted amide to substituted amine. You will get amine, means reaction is simple. Aniline is there, then first reaction of NH2 will take place. With benzene NH2 is attached, then reaction will take place there with NH2 only. Then NH2 plus acetic anhydride. Acetic anhydride formula you know, that is O in the middle, both side CH3CO. CH3CO is attached with oxygen with single bond. O in the middle, and that oxygen joining one side CH3CO. O is joining with carbon CH3CO, then C and O is double bond. Then bond will form from carbon and oxygen, middle oxygen. Same way other side. Then this aniline plus acetic anhydride reaction will take place in the presence of pyridine, which is a base. Then you know, already I told you that this acetic anhydride will break into the two part. Then one part will form, certainly it will form acetic acid. One form will form acetic acid, other form will be CH3CO. Then that CH3CO will join with N. Actually see that CH3CO, that CO, that carbon is positive charge, C plus, and NH2, H gone as H plus, N become negative. Then that carbon and nitrogen both will join. All thing will be as it is. Then you will get benzene was there already. Then NH, already NH2 was there. Then from this H has gone, and in its place CH3CO has joined. Then here you can see CH3CO, C was having positive charge, that's why it is electrophile, and H gone as H plus, that was also electrophile. That's why simply in the place of H plus this electrophile joined. Correct? Then you got a product that is a N-phenyl ethanamide. N-phenyl ethanamide, also called acid anilide. Acid anilide. But you want actually your this is there to get these things. Final product. Actually you want bromination. Correct? Then now this stage monosubstituted bromine, only one bromine you want to be attached, not three, not two, only one. For that purpose you have done acetylation. Now after that reaction will take place as it is. Via bromine. Now this compound acid anilide, also called N-phenyl ethanamide, it will react with bromine. Then same way what I discussed, Br2 will break into Br plus, Br minus. Then at para position, that it will join at para position. H will go as H plus, and there Br plus will go there. Because H will go as H plus, then carbon will come negative, and Br plus will join there. Then you will get para-bromo-aniline. You will get para-bromo-aniline, because what will happen that this H plus this H plus, actually here this reaction you are doing in presence of acetic acid. Then there what will happen, that here that this you have done acetylation, then now that will that is actually this compound is unstable. Then from the acetic acid this will react. Then what will happen, that this CH3CO which was attached to N, that bond will break, and in its place H plus will come. From where this H plus will come? Then it will come from the acetic side. Acetic acid was there, acid from there. Okay, or you can tell you have to do on hydrolysis. Acid hydrolysis you have to do. Then H plus you will get. Acid hydrolysis means then that time this bond N and C bond, NCO CH3 is there, style, that bond will break, N and C. Then it will go as a C double O CH3, C will be plus, and in its place H plus will join, because N will be negative, hence H plus will join. Then you will get finally 4-bromoaniline, correct? And this CH3 C double O, CH3 C double O, that will join with OH, and it will form acetic acid. CH3 C double OH, correct? Because when this bond will break, then you know that N will be negatively charged, and this CO CH3 will be positively charged. Then for this CO CH3, C is the positive charge, OH will join, OH minus will join. It will form CH3 C double OH, and H plus will join to the N. Hence you will get 4-bromoaniline. Okay, the lone pair of electrons on nitrogen of acid anilide interacts with oxygen atom due to the resonance reaction. Okay, you know that resonance with where is a single bond, that will come double, and where is a double, that will come single. Means NCO CH3 is there, then N and C single bond is there, and C double O double bond is there. Then now N and C, that N which is lone pair electron, that will make double bond with N and C, and C and O double bond will become single bond, means O will become negative charge. Okay, then where double bond was there, that became single bond, and where single bond was there, that became double bond. This is called actually resonance. Then this resonance takes place. Okay, this lone pair of electrons on nitrogen of acid anilide interacts with oxygen atom due to the resonance. Okay, hence the lone pair of electron on nitrogen is less available for donation to benzene ring by resonance. Therefore, activating effect of NHCO CH3 group is less than that of amine. How it is protecting, that I have told you, because now that this thing, the lone pair of electron on nitrogen, basicity was due to this only. The lone pair of electron on nitrogen is now less available for donation, because it took part in formation of double bond. Hence the lone pair of electrons on nitrogen is less available for donation to benzene ring by resonance. Therefore, activating effect of NHCO3 group is less than that of amino group. This question is asked. Okay, the activating effect of NHCO3 group is less than that of amino group. Now next reaction is nitration. Okay, nitration. This reaction also I have discussed, but now again I will here I will tell you, it will just, you will remember, you will not forget. Reaction is easy. Many times I have discussed. Then now nitration. Then nitration, here what will happen in nitration? NO2 will join. NO2, N will is positive charge. NO2 will have positive charge. How you will get NO2? Then you will get NO2 with when HNO3 and H2SO4, nitrating mixture, what you are telling. HNO3 plus H2SO4. When it will react, then during the reaction you will get plus NO2. Plus NO2. Why HNO3 and H2SO4 is required? I have already discussed, but again I am telling you hint that HNO3 from that actually OH will go outside as a OH minus. OH minus. HNO3 is there. Then from HNO3 OH will go. Then what will remain? NO2 will remain. Because it is going as OH minus. Then NO2 will be plus. N will have plus. Then now you understood from where NO2 is coming. Now what is the role of H2SO4? Then this OH minus will go to the benzene ring, and near the carbon, when benzene ring, near the carbon H is there. Every carbon has one H in benzene ring. Then it will go there. Then that H will leave there because OH has negative charge, hence it will attract. Then that H will leave the carbon as H plus. Then that H plus and this OH minus, it will form water. Then simply this reaction will not take place. That for there H2SO4 is there. It is compelling this CH bond to come here because that H2SO4, as soon as H2O will be formed, H plus and OH, it will on water, and that H2O will be quickly absorbed by H2SO4 because H2SO4 is dehydrating agent. Correct? Then carbon become negative charge. When hydrogen gone as H plus, carbon became negative. Then now this carbon is negative. Correct? And NO2 is positive, NO2 plus. Then it will make bond. NO2 will join with that carbon. Correct? Like this way NO2 is introduced in the benzene ring. Then here how NO2 is joining to benzene ring, I have told you. Main thing I have discussed. And direct nitration of aniline yields terry oxidation products. Terry, T-A-R-R-Y. Terry oxidation products in addition to nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form the anilinium ion because aniline has a lone pair electron. Hence, it is a basic nature. It can react with acid, and it can join with H plus by donating its lone pair of electron. Okay. Then here I told that you will get terry oxidation products in addition to the nitro derivative. Moreover, in the strongly acidic medium, aniline is protonated to form the aluminium ion, which is meta-directing. This anilinium ion is meta-directing, means substitution will take place at meta position. That is why beside the ortho and para derivative, significant amount of meta derivative is also formed. Okay, means already I told you that para position NO2 will join, then it will be main product 51%. Nitrobenzene, you will get nitroaniline. Then this is the at a para position 51%. Other will get meta position, that is the 47%. And third product you will get, that is very very less, that is the ortho position. Means NO2 can join ortho also, meta also, para also. Para will be always more percentage. Quantity will be more, 51%. And after that, second position is meta. Third position is ortho. You will ask why ortho position is less and para position is more. Then very simple things, always remember that in same things repulsion will be there. If two groups are same nature, then there will be repulsion. That's why they will prefer to go far, because in every molecule electrons will be there, then chances will be there for repulsion. Hence they want to make a distance. That's why para product will be more. Meta is again further more, 47%, because it is again a little far from the ortho. And if there is no position for para, no position for para and meta, then in the end it will form NO2 will join at ortho, but its percentage will be very less, 2%. Okay. However, by protecting the NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled and the para-nitro derivative can be obtained as the major product. Then what I discussed, that protection, same thing is here, same way with acetic anhydride reaction will take place in presence of pyridine. It will form acid anilide, already discussed. And again these things you want, when reaction will take place with HNO3 and H2SO4, then NO2 it will go to the para position. You want only at para position. That's why you have that you have protected the NH2 group. How? Then why? Acetylation with acetic anhydride. Then you will get a major product as para-nitro acid anilide. And after that hydrolysis you will do, then again you will get NH2, because COCH3 will go, means N and C bond will break. Then COCH3, that carbon is positive charge and nitrogen is negative charge. Then H2O, H plus will go to the nitrogen, it will form NH2, and C will join with OH minus, because C is positive, it will form CH3 COOH. Hence you will get only one product, para-nitroaniline. Now next next reaction I am telling you, that is the sulfonation reaction. Sulfonation means here SO3H group will join. SO3H, how will you get? H2SO4 is there. I want SO3H. Then obviously OH should come out. OH should come out from the H2SO4. Then you will get HSO3. This HSO3, S will have positive charge, because OH is going as a negative. Then only SO3H you will find that S will have positive charge. Then what will happen? Then it will go to the benzene. Then same way H will go as a H plus. Then in its H plus, SO3H that will join, because it also S is positive. SO3H, S is positive, electrophile, and it is positive charge, and H is going as H plus, that carbon become negative, hence SO3H will join there. This is called actually sulfonylate acid. It will join at a para position, but it will form intermediate, that is called anilinium hydrogen sulfate, because NH2 is there, that H plus, that NH2 one H can go as H plus, N will get negative charge. Then HSO4 actually join with N, but this is a temporary. It is called anilinium hydrogen sulfate, weak. Hence, after heating, what will happen? That now at para position H will come with this nitrogen, correct? It will form NH2, and this HSO4, which was positive, will come to the para position. That carbon is negative, there it will join. But means what I told in the beginning, directly it will give sulfonylate acid. Means at para position SO3H will join. Okay. Then now one more thing I am telling you. Now NH2 has lone pair of electron N. Then SO3H is there. Then that SO3H, from that it can go as a H plus. SO3H, that H can go as a H plus. Then SO3 will get negative charge, and this H plus will go to the NH2, because N has lone pair of electron, and it will form NH3 plus, because nitrogen has donated electron, hence it got 1 plus, Na plus NH2. Then now you can see here only in one molecule 2 sign you are getting. SO3 1 minus and NH3 1 plus. This is called deuter ion. This is called deuter ion. This is very, very important reaction. Aniline does not undergo Friedel-Crafts reaction, alkylation and acylation. Aniline does not undergo Friedel-Crafts reaction, that is alkylation and acylation and acetylation. Okay, it does not go Friedel-Crafts reaction, means alkylation and acetylation. Why? Due to salt formation with aluminum chloride, because here that it can form AlCl3 is required in Friedel-Crafts reaction, then that can form salt due to the salt formation with aluminum chloride. Okay, the Lewis aluminum chloride is Lewis acid, which is used as a catalyst in Friedel-Crafts reaction. Due to this nitrogen of aniline acquire positive charge and hence also act as a strong deactivating group for further reaction. Hence, aniline does not undergo Friedel-Crafts reaction. Okay, now I am stopping only here. This next reaction is very, very important, and it is long somewhat. Okay, I will discuss it, no problem. Then I will stop it. Diazonium salts. Okay, already diazonium salt last class I discussed. Here again, special I am focusing on diazonium salt formation. The diazonium salt have the general formula R into X. R into X on N2 plus charge on X minus charge, where R is an aryl group and X is an halide ion, maybe chloride, bromide, even the HSO4 minus also, BF4 minus also. Okay, X here may be Cl minus, Br minus, HSO4 minus, BF4 minus. Okay, they are named by suffixing diazonium to the name of the parent hydrocarbon from which they are formed, followed by the name of anion such as chloride, hydrogen chloride, etc. The N2 plus group is called diazonium group. Don't forget, N2 plus N2 plus this group, this is a group, this group is called diazonium group. For example, C6H5 N2Cl, N2 has positive charge, Cl is negative, is named as benzene diazonium chloride. Correct? N2 is the by azo group, you know. Then C6H5, that is the benzene diazonium. Benzene diazonium and chloride is there. Its name became benzene diazonium chloride. And same way C6H5N2, in the place of Cl minus, another minus you are adding, HSO4 minus, then it is known as benzene diazonium hydrogen sulfate. Benzene diazonium hydrogen sulfate. Primary aliphatic amines form highly unstable alkyl diazonium salts. Primary aromatic amines form arene diazonium salt, which are stable. Here you should understand, primary aliphatic amine form highly unstable alkyl diazonium salts, but primary aromatic amines form arene diazonium salt, which are stable for a short time in solution at low temperature, means around 273 to 278 Kelvin. This reaction already I have discussed. The stability of arene diazonium ion, already I told you that resonance structure will be there. Here in N2NN, triple bond is there. N and N, triple bond is there. Then one N has a lone pair of electron. N2 is joined with benzene with single bond. Then what will happen, that N has, in this N2 I told you N is a positive charge and N and N triple bond is there. Then what will happen, double bond in benzene ring, which is closer to the N from where it joined, that double bond of benzene ring will make a double bond with carbon and nitrogen, between carbon and nitrogen, from where N2 was attached to the benzene ring. There single bond was there. Now that is becoming double bond, because benzene double bond is breaking and it is making double bond with nitrogen and carbon. Now see, that became double bond. Then what will happen? Then triple bond was there, nitrogen NN. Then now one bond will break. Out of three, one bond will break. Then nitrogen will be taken, electron will be taken by another nitrogen, and one nitrogen that will get positive charge. Correct? One nitrogen will get negative, other will get one nitrogen will get positive charge and other will get negative. Now N became double bond. Correct? One N is positive and other N is negative. Now after that two structure I have discussed. Then now here I told you, when carbon and nitrogen became double bond, then benzene ring double bond broken. Then electron went to make the double bond with C and N, but that carbon that is the carbon number 6 will become positive charge. Then correct, that is positive charge. Then now what will happen, that nearest double bond from the positive in the ring, that bond will break, an electron will come to satisfy that positive and will make a double bond. And what was the double bond? That will break. That carbon will become negative, and which was positive, now that positive sign gone, it became neutral. And where bond broken, that carbon, from where electron gone, that became positive. correct? Again that positive want electron, then neighboring double bond will break and that positive charge will go and bond will be formed. Then from where this bond broken, that carbon from where it came, that became positive. Now positive charge now dispersed in the ring. From the sixth, now it reached to the second carbon. Then total 4 resonating structure you are getting. Okay, 4 resonating structure you are getting. Then that's why I'm telling this is the reason for stability. The stability of arene diazonium ion can be explained on the basis of resonance, because everywhere positive charge is dispersed. Okay, one N is positive, other N is negative. Both are double bond. Correct? Then this I have told about the stability of arene diazonium ion. And when ion is there, negative ion is there, then it can attract the positive. Okay, and it can form the salt. Then this I have told you that about the diazonium salt. Now I am stopping only here. Next class I will tell other properties. Other properties means these things, methods of preparation, this method of preparation of diazonium salts. Preparation of diazonium salts and its physical properties and chemical properties I will discuss next class. Thank you.